A concept key to this unit is the concept of linear momentum. Momentum is one of those funny words that we use in our everyday English language, but it has a different meaning in physics. In physics, momentum is defined by its equation, the fact that momentum, which uses the symbol p, is equal to its mass times its velocity. We'll notice those vector symbols on top of p and v, indicating that momentum is a vector, and it has the same direction as the velocity of our object. A fun fact is that Newton's second law was actually originally written in terms of momentum. Specifically, the way Newton wrote this law was he said that the time rate of change of the momentum of a particle is equal to the net force acting on the particle, and it's in the direction of that force. Anytime we see that time rate of change, that should indicate a derivative to you. So taking this expression and writing it in an equation, we see that the force is equal to the derivative of momentum with respect to time. Now we can go one step further with that equation. So using that definition for force, we can multiply both sides by dt to get the expression that the dp equals f dt. And then, as we've done a few times before, we're going to take the integral of both sides. In this case, we're going to look at from an initial time to a final time in both cases. And so on my left-hand side, we're going to get a change in momentum as we evaluate that momentum at its initial time and at its final time. And on my right-hand side, I'm leaving it as that integral. And the reason I'm doing that is because the right-hand side of this equation is what we call the impulse. The impulse, which uses a capital J, is equal to the integral of force over time. And the fact that that is equal to an object's change in momentum is called the impulse momentum theorem. We will apply this to several situations, and you'll find that it feels a lot like using forces and kinematics, and we can solve any problem that we've done with forces and kinematics using this impulse momentum theorem.